Okay, kind of screwed that up before, because I didn't write out the intermediate steps. And I just wrote out what I thought it would be, and that was done. Okay, so first, Laplace transform of the Heaviside function, shifted alpha units to the right. Well, if alpha is positive, then you can say, well, that's the integral from 0 to alpha of 0 e to the negative st dt, because up to alpha, the Heaviside function is 0, and then from alpha to infinity, it's 1. And that, of course, this integral is clearly 0, so you just get this. Okay, so writing out the steps as I should have done before, we get e to the negative st over s, and it's negative e to the negative st over s, evaluated between infinity and alpha. Okay, well, at infinity, clearly you're going to get 0. So it's going to be 0, and it's going to be minus the expression at alpha. And you've already got a minus, so it's going to be a plus. And then substituting alpha for t, you get e to the minus alpha s over s. So that's it. That's Laplace transform of h of t minus alpha. Now, you're probably still wondering what good this is. So the next question is, how could you combine two different Heaviside functions? Let's see, I said, okay, well, I described the function as being 0 outside the interval from 0 to 1 and 1 within that interval, right? So what we want to do is we want to say, okay, here we have a function that's 0 from here to here, 1 from here to here. And let me, since I'm going to be tracing over the x-axis, let me use different colors. And, with inclusive ends here, but 0 outside of this interval. So could you sketch me two Heaviside functions, or two multiples of Heaviside functions, of two transformed in parentheses? You might need to transform two functions. You might be able to use the Heaviside function and just transform one function. Okay? Two transformed Heaviside functions whose sum is given by the graph here, or the function that's described in words on your document.